So today we're talking about loops, which hopefully you've all seen during the pre-work. A lot of this should be reviewed, hopefully, and then just some kind of best practices for debugging, kind of common practices, or what are some best ways to some best practices to hopefully identify the error faster than normal. Um, the first loop we'll talk about is a while loop. While loops are something that people learn because they hold out kind of conceptual good content, but they're actually also not used as often, kind of in the wild in my experience. So a while loop takes three things. It has a while keyword, which we see there on line 6. It has a conditional, which is everything inside of the parentheses next to the while, and then we have a code block. And the basis for a while loop is just that block of code will run over and over again until the conditional reaches false, or at least until the conditional does not become true. Okay, so what that means is if I have this while loop here, I have my while keyword there on line 3, so I know that this is a while loop. My conditional is whatever's in the parentheses next to the while loop. So in this case, that will be count is greater than or equal to 1. And then I have my code block, which is everything in lines 4 and 5, right? And so what this is telling me is that code block, lines 4 and 5, will run nonstop until that conditional is no longer true. And so the conditional is saying is, hey, is count greater than or equal to 1, right? So this basically says, I will stop running once count is no longer greater than or equal to 1. Cool? That's like the basics of this while loop, right? And so a few nuances here that we're going to talk about then with a while loop is, one is if a conditional is false, right? If the first thing is not going to be true, then this will never run, right? It will check. The way the while loop works is it will check, run the code, check, run the code, check, run the code over and over again, right? So if the first check is false, it'll never run the code. It'll say, great, I'm done. I can go home. This loop will not run a single time. Alternatively, if you just hard code it as true, and this will always be true, you're going to get some kind of error where your computer is going to just run this thing infinite times, right? Is it true? Yes, run it. Is it true? Yes, run it. It will just not stop. In most cases, in most modern computers, once you run something like past an X number of times, the computer will shut it down for you and say, hey, I think you made a mistake here, or I think you meant to stop this earlier. But this is generally something that just to be careful of is that the point of having a conditional is that the conditional basically is going to be true, and eventually it will be false, right? Because you want this loop to run until a certain condition is met, and that means that in your code block, it's almost always necessary to make sure that your code block is moving your conditional closer and closer to the false state with each given run. So in this case, we have our count variable. Our code looks identical to before, except if we only run line 5, we're doing is at each state we're checking is 3 greater or equal to 1. It is, so we run console log, but we never change this count variable, right? And so it will always be 3, and 3 will always be greater than or equal to 1. And so that's why this particular while loop will never terminate, and it will run infinitely. Sorry. So just so you're aware, whenever you write a while loop, the biggest thing to kind of watch out for is just to make sure that somewhere either in your loop or somewhere kind of rationally speaking, your conditional will eventually become false. That's like the most important part of a while loop. The reason why I say will rationally become false is one common example people used to say is hey, let's just roll a die until I get a 6, right? So like even if your code block isn't explicitly saying stop after 100 tries, the inference is that reasonably speaking, at some point this while loop will finish. Yeah. Any questions? Hopefully while loops good review for the most part for folks. Yeah, great. So the next up is a for loop, and this is probably a lot more commonly used than a while loop. If you notice, a while loop is not indefinite, but a while loop could potentially be indefinite. A for loop is something that's usually used a little bit more kind of concretely, like usually you tell a for loop to run X number of times. And so the setup for a for loop is you have the for keyword. So on line 6 here, you see the for keyword. That tells JavaScript, hey, this is going to be a for loop. You have your parentheses still, but rather than having one conditional, you now have three things in there, and we'll talk about what those are in a little bit. And then line 7 is we still have our normal block of code. And so for a for loop, what a for loop kind of is designed to do is, if you look at the three things inside the parentheses, we have something called initialization, condition, and final expression. Okay, what initialization means is a for loop is designed to run X number of times, right? So initialization basically says, where do I start counting? Like, is the first thing 0? Is the first thing 10? Is the first thing, a string? Like, what is the first thing, right? Like, where do I start? And in every for loop, the initialization only runs once, right? Because you only start counting at one point. After that, you add numbers, you subtract numbers, you do whatever to it, but you only start once. The middle thing is condition, which is let's test to make sure is this condition true or false, much like in the while loop. What happens then is, rather than going to final condition right away, if this condition becomes true, we'll actually execute the block of code next, right? We'll run all the code that needs to be run, and then after all of this code finishes running, we'll do our final expression. And the final expression typically updates the condition. And then the condition will check again to see if it's true or not. If it's true, it will run the block of code, and it will do the final expression. And this mini loop here runs over and over until this condition becomes false. So what does that look like in real life? Yeah, so this is basically what I'm talking about. In this for loop here, can't really, but you can kind of tell this, let I equals 1, right? In this for loop here, the way that JavaScript is actually going to execute this for loop is, the first thing it's going to do is that it's going to say, hey, let's create a variable called I, and let's set it equal to 1. Okay? First thing it does. The next thing it does is, let me check my condition. Is 1 less than or equal to 3? And the answer is yes, it is. Great. So then it jumps to the code block and says, console log out for me whatever this is. And in this case, we're console logging out I is 1. Right? After this code block finishes running, then we go to the third part, the final expression. And what this does is, this basically just adds 1 to number I, right? And that's kind of like one iteration. The next iteration then becomes, all right, now that we've added 1 to I is now what? 2. Is 2 less than or equal to 3? The answer is yes. So we're going to run our code block. We're going to say, I is 2. And then we're going to run our final expression again and add 1 more to 2. So now I is 3. Is I equal to 3 or less than or equal to 3? And there's yes. So we run our code block. We run I is 3, and then we run this again. So what's 3 plus 1 net here? 4, right? And this is the most important. This is an important part of for loops that hopefully you can kind of tell like JavaScript does another loop, or at least it tries to. It will check, is 4 less than or equal to 3? And the answer is no. So at that point, it will stop. Okay? It doesn't hit this and just say, okay, this looks about like a starting point, I'll stop. It actually tries to evaluate this conditional. And if this conditional is true, it will keep running. If it's false, it will stop. And so when you write for loops for some of the workshops today, just kind of in the back of your mind, keep track of at what point is JavaScript actually going to be testing this. Is it it tests it before the code block runs. So if you wanted to, you might see, or sometimes you might see your code running 1 extra cycle than you intended for it to. It's probably because you're not setting the condition right, and your condition is 1 step later than we think it is. Because JavaScript will always test your conditional 1 extra time, and that extra time has to be false. Otherwise, it will just keep running. So for a for loop, one of the things that you'll notice is that here, we kept adding 1, but really, at this point, there's nothing kind of directional about this, right? We're just saying, hey, let's start here, let's check this, let's run our code, and then let's do this, right? That do this could be adding a number, it could be subtracting a number, it could be multiplying a number, it could be really anything you want. There's no criteria limited there, right? And so it's also, so when we talk about looping, it's very fluid, and we can also loop in when we say either direction. It just means, hey, we can go, if we're going through a list, we can start at the first thing and work our way 1 by 1 down to the last thing, or we can start at the last thing and work our way back one by one to the very first thing. We can skip every other thing we want. We can go to every third thing we want. We can jump based on some random number if we really wanted to, right? There's really no limit, right? So even though traditionally when you see a for loop, it will be incrementing left to right by 1. That's not a hard and fast rule. It's just commonly people think that way and they do it that way, but it's by no means a requirement in a for loop. You can do whatever you want in the for loop as long as you're following those kind of 4 steps of having it evaluate in a certain way. Yeah. So here we're just, instead of incrementing by 1, we're incrementing by 100. Same idea, nothing's different. And then one of the things that you do a lot in this class is, conceptually that's what a for loop is. Let's talk about how we use it in the real world. One of the most common use cases for a for loop is to iterate through a string, right? A string it's a collection of letters and spaces and symbols, right? So a string has a length. And so one common use of a for loop is we start at 0 because the first element in the string starts at index 0, and we just work our way left to right, incrementing by 1, and at each phase we just print out the letter. So when we do this, we actually are able to go through every single letter in a string. Okay, so that's just like a common use case of for loops. We're gonna have a lot more quote unquote common use cases of for loops going on or moving forward as well. Any questions on for loops or while loops for that matter? Yes.
So you can basically put any code, even functions and arrays inside of the for loop. It's just containing all that.
Yep. Yep.
I got a quick question. So here, because you're looping through a string.
Yep.
When you try to access the let E, you say letters and then the E like an index.
Yep, the I, you mean?
Yeah, the I, sorry.
Yeah.
But if you use numbers, do you also need to put that index, or you put just I because it's a number?
Yeah, so if you want to access, so in this case, what is I at every instance?
Each letter.
No, what is I?
Where you start.
Right, but what data type is I?
Number.
I is a number, right? So because we start I equals 0, right, and we're only adding numbers to it, so we never change what I is, right? I is always going to be a number, right? So in this case, the I is just going to tell us a position number, right? And the actual letter is actually by saying, give me the thing at position 5 in this string, right? So if you wanted the position, then you would use I. And if you wanted the letter, you would need to say, hey, give me the thing at position 5. And so this is actually a very common kind of kind of confusing thing when you first start off is the I is, in this case, for this example, the I is just a position, and the element is what's at that position. Right, so if I don't know how to kind of think right now, but I'm blanking right now on it, honestly. But it's almost like saying the I is almost like the address, right? And then the element is the actual house at that address, right? So those two are very different things. And when you think about accessing something, it's almost very important to know that okay, do I want the element there, or do I just want to know where it is? Because depending on what you want, you're gonna be using different parts of the for loop. Yeah. I mean, the let I there should be very clear, right? We're just kind of creating this temporary variable almost that persists as we go through this for loop, and each time we go through it, each time we go to the next thing, we're adding 1 to it. So it kind of is it's like another playing variable almost. Cool. Okay, so while loops. Oh, sorry. You have a question, Joanne? Or okay. Yeah.
Oh no.
Okay. Sorry. Any other questions on while loops and for loops? All right. Cool. So next thing we're gonna talk about is kind of So loops kind of, by default are gonna run. They're gonna kind of finish up what they were supposed to do. But there are a few things we can do to kind of in the middle of loops to kind of cut it off, kind of without it naturally progressing to its natural end state. So there's something called the continue keyword. And what the continue keyword will do is, let's say in this case, the for loop runs, it looks like 5 times, right? We start at 1, we increment by 1, and we stop once it's no longer less than or equal to 5. So it's going to run 5 times. What the continue keyword does is, at each single loop, it will actually let you kind of stop that iteration at a certain point and move on to the next iteration. So when we look at the outputs of what happens when we run this code, right? When we start at 1, we go through here, right? And if you notice, the continue is embedded in this if block, if I is 3, right? So when I is 1, I equals 2, we never hit this if block, or rather we never go inside this if block, so we can just almost ignore it when I equals 1 and when I equals 2. So when I equals 1, we just console log out I is 1. When I equals 2, we console log out I is 2. When I is 3, we then go into this if block, and we hit this continue. At that point, what continue does is it will tell you, hey, we're done with this iteration. I don't care what other code's underneath me. Stop it. Like, we're going to move on to the next iteration. So after we hit continue, we immediately jump to this next final expression phase, and we add 1 to I. We add 1 to I is now 4. And so, once again, for 4 and 5, we still skip this if loop, right? Because it's no longer 3 anymore. And so we log out I is 4 and I is 5. But essentially what this continue does is it gives us a way to kind of jump immediately to the next iteration of the loop without running any subsequent code. So it's a good way for you to say, hey, I want the rest of this loop to finish running, but in this case, like I've reached my endpoint, if you will. Does that make sense? Hopefully? Yeah. And then the next, and then this also works in a while loop as well. Is that whenever you hit the continue, it will basically just jump to the next iteration of this loop. So in this case, this modulo 2 basically checks to see if this number is even or not, and it's saying if it's even, go to the next one. Otherwise, count is this, and then decrement count by 1. So when we do it, what we're doing is we're actually only printing out the odd numbers, right? Because we're saying if this number is even, go to the next iteration. If it's odd, then we do this. Yeah.
On the previous page.
Yeah.
We've got, I don't know, on the one I've got here, I've got if count modulus 2 is equal to 0, I've got count minus minus and then continue.
Sorry, you got what?
On line 6, for your line 6, I've got a line just before that says count minus minus.
Oh, that's a typo. You're right. That's a typo. I think I'm using an older version. So this should be here.
Then I still have it on my email as well.
Yeah, you have to. So yeah, so let's talk about why that is, or why without this function kind of breaks down here. Okay. What we really want to say here is, if count is even and we go to continue, what's the next iteration of count going to be? It'll be the same number still, right? And so we're basically going to be trapped in this infinite loop here, where we're going to say, is count even? Yes, continue. Is count even? Yes, continue over and over again, right? At no point are we ever, to our earlier example, at no point are we ever moving count towards like a final state or like a state in which this is false, right? And so that's why, regardless of whether or not it's even, if it's even, we want to decrease it by 1, and then we move on to the next iteration. If it's not even, we want to print it out, but we still want to decrease it by 1 before we move on to the next iteration. So in every single instance here, we still want to move on to the next number. It's just a matter of, do we want to print it out before we move on to the next number, or do we want to just like move on to the next number directly? So good catch there. Yep. Cool. All right. Break, on the other hand, basically says, hey, I just want to get out of this for loop altogether, right? Like, I don't want you to go on to the next iteration. I'm just like done with this loop. And so we can use it in a while loop here, where basically it says, in this case, the problem is saying is, hey, I want to basically get it so that I want to get an A plus plus. If I have an A, keep adding pluses to it until I hit A plus plus, at which point you can stop because it's kind of overkill. But if we hit break, notice how this while loop is true, right? And really, if we don't have a continue or we don't have a break inside of here, this is going to run infinitely, right? True will always be true, so this while loop will never ever stop running. So by having this break here, what we're actually saying is, hey, you know what? Don't even bother checking it. There is no next cycle. When I hit break, we move on to the next line after the while loop. And so this is why break is really powerful too, is that it's not always, quote unquote, possible to have like an infinitely running thing here, as long as somewhere in the loop you're able to break out of it. And that could be done either through the checking conditions, or in kind of more extreme cases, you want to break out of it with the break word, which just kind of lets you leave the loop altogether. If we look at this in the context of a for loop, what the loop is designed to do is start at 10 and then print every number while working our way down one by one. And if you notice, whereas before when we use continue, we skipped one number, but we kept going under the next number. Here, when we hit 7, we hit break, and this entire for loop is finished. We never go to 6, 5, 4, 3, 2, 1. Like we're just done at that point. And so break. So whereas continue lets you go on to the next iteration of the loop, break just stops the entire loop altogether at that point in time. So nothing after it is going to run. Yeah, Emily?
But you could achieve the same thing by putting it in the condition as well,
Yep,
right?
you absolutely could.
What's the difference between, like, what are the instances when you would choose break over putting it in the conditional?
Yeah, so you basically use break. So one like example of when you would use break is if I have a list of 10 things, I'm looking for the first match, and once I find it, I want to stop. In that case, I want like my condition to say looks through every single thing. But if I find a match, then I'll just break and I'll stop right there. Otherwise, look through every single thing. So typically with breaks, you more or less tend to use it when you don't know when to break, but you have a certain condition that's going to be met, in which case you are going to break out of it. So break is something that's it's not as commonly used. I think most folks there's other ways to do it. But when you see it, like don't freak out. That's all it's doing is that when you see a break, it just means kill the loop at that point. All right. Okay. So any questions on the continue, break, while, and for loops? Went through a little bit fast, but hopefully that was mostly review for all of you. At least the loop parts, hopefully. All right. Great. All right. So some general debugging best practices. Developers like when you think of developers, you might think of someone who just writes a lot of code really quickly. But like I said earlier, more than half my time is spent reading code, and then probably 20 to 30% of my time is spent fixing code. And so the point in which you're writing code by yourself, writing brand new code, is actually very little, right? It's like understanding a problem. Solving a problem is more about understanding the problem than it is about solving it. Once you understand it well enough or properly, solving it almost becomes easy because it's very clear what you need to be doing. More often than not, when you write code, the first time you run it, it's going to break, and it's going to break of some very silly reasons. Sometimes it could be fundamentally you had bad logic, but more often than not, it'll be because you use a variable that didn't exist yet, or you did something out of order, or there was a special edge case that kind of flared up, and your data and your functions aren't running properly. So for this at least, we'll just give you some really quick tips on debugging. They're not meant to be like a solve-all by any means, but they're just things that you can use to hopefully kind of as you run code, when you see a break, you can hopefully save you a little bit of time in terms of figuring out what actually went wrong. So error messages. Error messages are really great because they tell you, more often than not, they will tell you they'll give you an idea of where to start looking for the error. So this is what you see on the bottom of your screen in CodePen when you run your tests. For a traditional error screen, what it's going to do is it's going to give you the test that failed. It will tell you what error actually triggered it, but then it will actually tell you all the lines leading up to that error. The computer will say, "I tried running this line, worked great. Try running this line, then worked great. try running this line, and then this error happened. So it's not just this error happened. It's like here's how far I made it, and around when the error happened. So when you look at this particular error screen, it works upwards. So the line at the top is the most recent line that was run, right? And then second most recent, third most recent, etc., etc. So when you see an error type, if you're not familiar with what type of error it is, Google it or at least look it up to at least have a sense of kind of why this happened, right? So a reference error. Reference errors usually means something you're trying to use a variable that has not been created yet. So you could be calling a function that doesn't exist, right? This will happen mostly for two reasons. One is because you created it somewhere else on the page and you're using it kind of before it was available to be used. Or two is you have a typo somewhere and you might have a variable called my favorite place. You forget the L and you wrote my favorite pace, right? And JavaScript will say, hey, this my favorite pace variable doesn't exist. And you kind of, as you walk through the errors, as you see more of these, you'll be able to see, okay, it looks like the last line that was running was this file on, and then you'll see two numbers separated by a colon. The first number is usually the line number, and the second number is the character number. The character number, not nearly as important. Usually the line number will give you what you need to kind of start figuring out where it's broken. Now, this is by no means like a catch-all. Like a lot of times the error happens more downstream of where the error that happens is not kind of where the error was caused. And the reason for that is because most computer programming languages, most of them don't really have like good quote unquote like safety checks, right? So what I mean by that is the way that the JavaScript will normally run your code is it will try running it, and if it breaks, it will tell you. But before it tries, it has no idea of what it's trying to do is correct or not. So an example is, let's say I want to invoke a function, right? I invoke a function with the open and close parentheses, right? Now, before JavaScript tries to invoke that function, there's not really it won't tell you, hey David, this is not a function, don't invoke it. It will try invoking it and it will fail, right? And so because of that, the error that I'm going to get is saying, hey, this thing's not a function. That's great. But the error was probably caused when I created that thing, right? And I could have created that thing somewhere else on the page. And so that's all I'm trying to say here is that like wherever this line number is, like that's where the error manifests itself. It may not be where the error created itself. Once you find this, try to figure out how the error manifested. Think about how it could have been caused, and then try to go through your code just to kind of see where the error could have originated. Don't just go to that line blindly and think that, oh, that must be where the error is, because in a lot of cases, it's not. Yeah, so this is a reiteration of kind of what I said. Okay, failing tests. If your code runs successfully, but you just get the wrong answer back, a lot of times you'll see the test in some kind of syntax saying, I expected blank, but I got blank, or I expected this to equal this. The first number is basically what the right answer is. The second one is what it actually got. And so in this case, you know that your code ran correctly. It just did, there was no errors. It just gave you back the wrong answer, right? And so if you look at these, the little dots and X up top tell you the number of tests. And obviously the red X's are kind of which tests you failed. The tests run in sequential order. So if you see the third test failing here, if you look in CodePen, it will be the third test that was running that failed. So it should be pretty fast for you to kind of go back and really quickly identify which ones have been failing. Yeah. And then lastly, is the other thing you want to do is when your tests fail, just look at the test itself, right? Figure out what the test is doing. With every test, it's very clearly what it's trying to do, right? If you write a function called, my new function, you will see it run let x equals my new function. I'll pass in an argument, and then below it will say I expect x to equal this, right? So that when you look at the test that's failing, you're like, I don't understand how this could possibly be. Try running the code the way the test is running it, and at every single stage, you should get what the test gets. Let me know if it's not the case, but in almost all cases, that's what's going to happen, right? So if you have trouble passing a test, try to recreate the test almost on your own side, so you can see the problem or see the code run the way that the test is. Okay. And this is something that's a little bit more like it's this one I don't use it as much, but we just kind of want to throw it out there. It is something that that certain developers use quite heavily. It's this debugger keyword here. What debugger does is debugger basically runs this code and it will stop at a certain point and say, okay, right now this is the state of the world as is, right? And when you use a debugger, you'll have the option of having JavaScript run each subsequent line by line. Basically, you're saying, all right, slow everything down. Don't run the next line of code until I give you permission to. And so, how that looks in real life is hopefully everyone here has seen the Chrome developer tools before. If you don't have access to it, it's just you can right click anywhere on the page and click inspect. This will open up this little kind of box for you, and this is basically Chrome, right? And when we say you can run JavaScript anywhere in Chrome or on your computer, like this is it, right? So I can do like let David equal 5, right? And I can do David plus 10, and it'll give me 15 back, right? Here basically it allows you to run JavaScript. On the other hand, if I want to run a function, for example, I have this function here that I want to run. If I actually run style me pretty, actually no, sorry. Style me pretty, and I'll put a debugger here. When I try running it, it will actually get to the point of the debugger. It will in Chrome, it will get me to the point of debugger, and it will kind of stop and await my next direction to say, okay, I reached this line successfully. Now, what do you want me to do? And now Chrome at least gives you a bunch of tools to be able to go through and say, oh, like I want to kind of check to see what variables have been created. It looks like not much. I have this inner beauty variable that was or this inner beauty function that was hoisted up, and if I click on yeah, so then when I click on this arrow, it'll take me to the next line of code that's running, right? It'll skip over all this function stuff because this is defining a function that I may or may not use. The next line of code that actually runs is going to be truth plus or equal inner beauty 5. And so if I click on the arrow again here, it will actually go into the inner beauty function, and I can see it run step by step. So this is another tool for you to use if you want to use it. It basically allows you to slow down the code and run through it line by line. Up to you if you want to use this or not. We're just throwing it out here because it is a common thing that people use kind of in the wild, so to speak. All right. So that's pretty much it. We talked about loops, we talked about break and continues, and we talked about a few things of how to kind of read the errors and the tests, and passing the tests on CodePen. Any questions? All good? Did we lose someone? No, we didn't. I lied. I just counted. Did lose someone, didn't we? It's 14 of you. Should be 15. Oh. Yeah. All right, cool. So, all right.